All right, here's the solution to a rate story from 2022. So let's read it together. From 5 a.m. to 10 a.m., the rate at which the vehicles arrive at a certain toll plaza is given by that equation. T is the number of hours after 5 a.m. and A at T is measured in vehicles per hour. The traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. So I'm going to back up here. This is from 5 a.m. to 10 a.m. and this equation is a rate. So this is already a derivative, hence a rate story. Part A says, write but don't evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. If you're asked for how many, the total, and you have a rate equation, to find how many, we integrate. So on paper, we're going to do on a separate piece of paper here, write down the year and the rate story. So this is from 2022 and it's a rate story. Notice it's question number 1, so it's with the calculator, but this one is not a calculator question. So we're going to integrate from 1 to 5 and just write that equation down. But don't evaluate it, it says. Part B. Find the average value of this rate in vehicles per hour at which vehicles arrive from 1 to 5. How do you find the average value of a function? Also, an integration question. So we're going to do the same integration 1 to 5. But when you find the average value, you divide by the difference of the bounds. So we're going to put this in our calculator. So I need you to press pause and open up Desmos. And for all these stories, if we have an equation, we're going to use it more than once. So I'm going to just take one box and type in the equation. Then I'll do calculus in another box. And I got to make sure that I'm typing it in correctly. So I'm going to double check here. That wasn't right. So we're going to do square root, then that. So square root sine 0.62 t. So double checking. I think we're good. So that's what that equation is. So now I'm going to do what it says. Can you find the average value? So in the numerator, we're going to do the integration. So I'm going to go functions and go down to calculus. And I'm integrating from 1 to 5. And I'm integrating this so I don't have to retype it in. And then in the denominator is 5, take away 1 or 4. And then I have my answer. Now it's a rate, and we're going to go to 3 numbers after the decimal. So 0.536. And then we need to include the correct units, which is vehicles per hour. And then I got to double check to make sure that the question didn't ask to explain something. So I did the work to find the average value. Does it say to explain or give a reason? And I don't see that, so part B is done. Part C. Press pause if it's going too fast. Is the rate at which vehicles arrive at the toll plaza at 6 a.m. increasing or decreasing, and give an answer? So is the rate increasing? So to know if a rate is increasing or decreasing, we take the derivative of the rate and see if it gives you a positive value or a negative value. So I'm going to take the derivative at that number, which is 1 for this equation. And so I'm going to use my calculator again. And notice because I did that first box, I don't have to retype it in every time. So I'm going to go A, the derivative, just the apostrophe, and then the number. So it is at 1. So when I look at that, I'm going to write the answer down. Now the unit here would be vehicles per hour, or per hour squared. And then again, I'm going to double check. Do I need to give a reason for it? And it says yes. Is it increasing or decreasing, and give a reason. So the rate at which vehicles are arriving is increasing at 6 a.m., that's the time, because, and then I'm going to write this down. You could write it in different ways, but we know the derivative is positive or greater than 0. This is the reason we said the word increasing compared to decreasing. You could write down A prime at 1 is positive, and that would be the same great answer. All right, one more left, D. A line forms whenever this rate is bigger than 400. The number of vehicles in line from A to 4 is given by this equation. And we already know A in terms of the smallest number is 0 or 5 a.m. Where A is the time when a line first begins to form. To the nearest whole number, find that number to the nearest great and so on. So there's a couple questions here. So A is the time when a line first forms. So a line first forms when it's bigger or equal to 400. And how do I do that? So the first thing I'm going to find is A, and we'll set this up. So back to Desmos. Now, this red equation here, I'm going to put a restriction on it. So I'm going to use some fancy parentheses, and I'm going to put in a restriction from 0 to 4. That way, that's all I see is the graph from 0 to 4. And then I'm going to zoom out so I can see it better, and then kind of zoom in so I can kind of see what's happening here. And I'm interested in that 400, right? So that's why I'm kind of moving the graph around so I can see 400. So right here is 400, and it goes up from there. But you can see what the graph is doing. So I'm going to do another line. I'm just going to type in y equals 400. So if I type in y equals 400 and look off my graph, that's this purple line right here. Now, why did I write that in, y equals 400? So I could see the answer at what two numbers is the rate equal to 400 or bigger. So first of all, a line first starts to form when A equals 1.469. So I'm going to go back to my sheet for part D and say A equals approximately 1.469. And that is the time when a line first begins to form. And when does it, and so if you look at when it's above 400 or equal to, the other end is at 3.5977 or 97. So first, at what time does a line begin to form? It's when it's bigger or equal to 400. So the first time it is equal to 400 or bigger is at 1.469. And all the values between 1.469 and 3.597 on the graph, they're all 400 or bigger. So this is the range for it being bigger than or equal to 400. Then it says find the greatest number of vehicles in line at that time using that equation. So I'm going to write down the equation. Now, if I want to know the greatest number, that's another word for maximum. So if I have an equation to find the maximum of something, we take the derivative and we make it equal to 0. So the derivative of this, remember they cross out, I plug in t and I get a at t minus 400. So just think of this as one equation and you just plug it in. So they cross out, the t gets plugged in for x, and this whole thing. Don't take the derivative of negative 400 and make it 0. It's not that type of equation. Take the derivative. The derivative and integration, that's where they cross out, and then you plug in, and that's your answer. Make it equal to 0, because when you find the maximum or minimum, you take the derivative equal to 0, solve it. So add 400, and we already found this. Can you tell me when this is true? We equal, this is those numbers, right? 1.469 and 3.597. So we're going to do a table of values. And it says from A to 4. And we need to find it. From A is 1.469. Another critical number is 3.597. And the other end is 4, is the right end. So when you read the question, it says from A to 4, those are the ends. And we said A was 1.469, so the other end is 4, and the critical number in the middle is 3.597. And then we need to find the number of vehicles. And then how would I find the number of vehicles? And do the math involved. So how many involves to integrate what I'm looking at? So I'm going to plug in 1.469 Now, if I integrate using this equation, so now we know that A is 1.469 to t. So if I plug in 1.469, when I integrate and the top number and bottom number are the same, there is no area, that's 0. That means that there's no vehicles waiting, because they just started at that time. The second one I need to figure out is at 3.597. So I'm going to integrate from 1.469 to that number, 3.597. And I'm going to use my calculator. So for this one, I need to type that in. So I'm going to integrate. In this case, again, I'm integrating 1.469 to 3.597. And then we have, and we use t, right? Not x. So I'm just going to say t. Minus 400. And then I think in the question it says round to a whole number. To the nearest whole number. So in part D it says to the nearest whole number. So that would be 71. Then I'm going to set this up again for 4. So I'm going to integrate 1.469 to 4. Now I already have it set up, so I'm not going to retype everything in. So I'm just going to change that number on top to 4. And I get 62. All right, I am done. And I'm just there at 15 minutes. So the question is, find the greatest number of vehicles in line. So the greatest number of vehicles in line is about 71. And we did it. just under 15 minutes. All right, let's look at the second question that we're doing. So that was from 2022. If you need a break, press pause. Here's the second question for your homework, 2019. So when you're ready, let's read this together, and then your homework is done. Fish enter a lake at a rate modeled by this. So E represents fish entering a lake. Fish leave the lake modeled by this. So this is a common question where one rate represents something going in and some rate represents something going out. So E at T is entering fish, L at T, and they both are rates, and they're measured in fish per hour. Since midnight and T equals 0 is midnight. All right, so I'm double checking that both the equations are rates and what they represent. E is fish entering, L is fish leaving. Here we go. Part A, how many fish enter the lake over the 5-hour period from 0 to 5? Give your answer. So once you have a rate, how do you answer how many? And the answer is, I'm going to answer right on the sheet here. The answer for how many is you integrate. So I'm going to integrate from 0 to 5, and I'm only integrating the fish entering the lake. So I'm just entering E, and because it's already defined, I'm going to put it there, and then I'm going to use my calculator, and I'm just going to get the answer to a whole number. Now I recognize we have two equations, so to save time, I'm going to type in both equations. So I'm going to get rid of this from the first question. And before I get too far here, I'm going to write E at T equals, and I'm going to be careful and type it in. It's usually an ugly equation. This one isn't too bad. Pi is right here. And that's pi T over 6. Okay, double, check. Did I type it in correctly? Then the second equation, I'm going to do the same thing. 4 plus 2 to the exponent 0.1 t squared. Did I do that right? 4 plus t to the exponent 0.1 t squared. I like it. All right, now I can start answering it. So the first one is just integrate. Super easy, very foundation question. So from 0 to 5, and then I type in, and I don't have to retype in everything, and then to the nearest whole number, that number would be 153 fish. All right, we're off and running. B, what is the average number? That would be average value that they leave the lake per hour. So recognize which equation you're doing, and then recognize, I'm going to do it down here. So how do I find average value? That's an integration question. I'm going to integrate from 0 to 5. Which equation am I finding the average value of? The leaving part. And then you divide by the difference of the bounds. And again, are we going to round to the nearest or not? No. So I'm going to go back to my calculator and type that in. And then in the numerator, we're leaving. Oh, you know what? I didn't like how I typed this in. So let's do it again. Let's start with a fraction. The whole numerator should be an integration. So it's not inside the integration. You start with a fraction, and the numerator is that integration. And again, I'm integrating from 0 to 5. I'm integrating L. And then in the denominator is 5 take away 0, or 5. And then didn't say to round, so I'm going to use 3 numbers after, which is 6.059, and I need units. And the unit for the rate, because it's an average rate, is fish per hour. And then I double check to make sure, do I need to explain what that means? What is the average number thing? I don't have to explain it. So part B is done. Part C. This one's longer. I'm going to go here. I'm going to switch where I do it. So in part C, it says at what time from 0 to 8 is the greatest number of fish in the lake? So I'm not looking for the greatest number, but what the time it happens, and to justify my answer. So from 0 to 8, the greatest number of fish, we got to involve both equations. Now, is there any fish in the lake to begin with? So fish enter, fish leave are measured and T is measured in that. And there's no description here to describe that there's some fish. So I'm double checking to make sure there's not like 20 fish to begin with, because I'd have to include that. So T is there. How would I know how many fish are in the lake? You take the fish that are entering and subtract the fish that are leaving, and they both are rates. So you would integrate that to see how many and then try to figure out that. So what I'm going to do is this. I'm going to set up an equation. I'm just going to call it y. And my bounds start with the beginning time, which is 0. And they go to some time t. And we know that it's from 0 to 8, ultimately. And this equation will give me how many fish there are at any time. So if I plug in 1 for t, it'll tell me that, and it'll add up at 1 hour how many entered, how many left, and would subtract the two and put it all together in one equation. So I know the first two numbers I need to use in that equation are 0 and 8. So at 0, go 0 to 0, there are no fish in the lake. At 8, that's 0 to 8, we need to put that in the calculator. Now, where else do I need to do? I can do that right now and go back from 0 to 8. So another box here, I'm going to integrate from 0 to 8. And once I have a template, I can just go back and not have to retype it all in. All right, so I get 80.919. And if I did say to round, nah, it doesn't matter. 80.919, because it's not even the number of fish. They just want to know the time. But to find the maximum number, I got to take the derivative equal to 0. So I'm going to take the derivative of this. So if I take the derivative, they undo each other. And really, this should be to x, not t. Or this should be x and not t. It doesn't matter. When I take the derivative, you're just left with this. So this really should be t, and this is x. So when I take the derivative, you just plug t in for x, and that's it. They cross out. And then I make it equal to 0. To solve this, we're going to add L at t to the other side and recognize whenever they're equal to each other, that's a critical number. So I'm going to go to my graph here. I'm going to go, when are they equal to each other from 0 to 8? So I'm going to go back here. And for both of these, I'm going to put a restriction from 0 to 8. So it's good to know how to put a restriction in the calculator. So again, from 0 to 8. And then I'm going to look off my graph. So what I'm looking for is where they're equal to each other. So make sure that's the only spot they cross, which it is. So at what number are they equal to each other on the graph? And that's when t equals 6.203. That's what I'm going to say. Then I'm going to use that number, 0 and put it back in this equation. So instead of 8, erase it and put in 6. What was that number again? 203. And I get 135.0149 or 14, and then I can answer the question. So at what time do we have the most amount of fish in the lake? And the time is there. So at t equals 6.203, and the unit is in hours since midnight. Is the time for the greatest number of fish in the lake. I try to be a good reader, so recognize they are asking for the time, not for the maximum number of fish. If they ask for the maximum number of fish, maybe rounded, it would be 135. But at what time do you have a max? There it is. All right, part D. last part, we're almost there, under 30 minutes. Is the rate of change in the number of fish in the lake increasing or decreasing at that time? So, is the rate increasing or decreasing is a derivative of a derivative. So, to understand that, remember the derivative was right here. So the derivative of a derivative, the second derivative, at that number 5 would be the derivative at 5 minus the derivative of L at 5. So we have here, now what that rate, is it increasing or decreasing at 5, means you take the derivative of that derivative and plug in 5 and then use your calculator. So this is why we have this set up, another box. E, derivative at 5, subtract L, derivative at 5, and you can see the answer. So it's negative 10.722. Let's go back. That is fish per hour per hour. And then, do we need to explain the meaning? It says, yeah, explain the reason of it. Is it increasing or decreasing? So, at what time? At 5 a.m., the rate of change in the number of fish is increasing or decreasing. What's the indicator? Is decreasing since or because. Decreasing, there we go. That's the word I'm looking for. Because. And why is it? That's because the derivative, this derivative, is less than 0, or you could say it's negative. Done. Mr. G, math, over and out. I'm proud of you for doing your best. You should try the questions again from the beginning and see if you can do it and understand. And I know you're doing your best. Till next time.